Okay, welcome to 4.2. We're going to learn how to factor quadratic equations today. So in our warm-up, we are going to FOIL a bunch of binomials and turn them into quadratics so that we can start recognizing patterns in what happens when we FOIL certain types and how we might go about moving them backwards from a quadratic back into their component binomial factors. So we've all had experience with foiling before. So start with the first term, x squared, then the outsides, so that's plus 3x, then the insides, that's minus 3x, and then finally the last two terms, which is minus 9. Of course, these two terms are going to cancel each other off, and we get x squared minus 9. So notice that this is a perfect square and this is a perfect square, and they're separated by a minus sign, and that came from two identical terms with opposite signs. Okay, so keep that in mind as we move forward. Here again, two identical terms with opposite signs. So let's see if we continue the trend. First, 3x times 3x is 9x squared. Then we go, plus 24x minus 24x. Okay, so that's the importance of having the opposite signs here, is that these two terms will always completely cancel each other out if everything else is identical and the signs are opposite. And then finally we go minus 64y squared. And of course these will be eliminated, and we get 9x squared minus 64y squared. And again, take notice of what's going on here. Here we had a perfect square minus a perfect square, okay, the square of x and the square of 3. Here we have a perfect square, the square of 3x, minus a perfect square, the square of 8y. Now what if the signs are the same? Well, let's take a look. First term, 4m squared. Outside is minus 6m. Minus 6m. Inside is minus 6m. And the last terms are plus 9, so we get 4m squared minus 12m plus 9. The next one, similar thing but with adding instead of subtracting. This will be 16x squared, and then we'll go plus 20xy, 20xy, then here plus 20xy, and then finally the last, which is plus 25y squared, which simplifies to 16x squared plus 40xy plus 25y squared. Alright. Finally, when the terms are not identical, the first thing I'm going to do is point out the sum of these two terms. Negative 7 and negative 2 add up to minus 9, and negative 7 times negative 2 will multiply together to give you 14. So this is the product. So let's see what happens here. X squared, then we go minus 2x minus 7x, and then plus 14, which gives us x squared minus 9x plus 14. Alright, now notice that when we added those two numbers, they gave us that, and when we multiplied those two numbers, they gave us a positive 14. So let's see if that same thing works for the next one here. we have 5 and 3. They add up to 8, so that's the sum. And they multiply together to give you 15, so that's the product. So let's see. X squared plus 3x plus 5x, and then finally plus 15, and of course this simplifies to x squared plus 8x plus 15. So again, it worked. We were able to successfully predict what was going on with our linear term and our constant term just by doing a quick sum and product. Now factoring is working backwards from what we were just doing. So basically what we want to do first is always check for a greatest common factor. So anything that's common to both of these, we want to take out as much of it as we possibly can. 8 is not common because 28 does not divide evenly by 8, but it will divide evenly by 4. Both of them will. So we can take out a 4, and notice that this one has 2 A's in it and this one has 1 A. Now we can't take out 2 A's because this guy doesn't have 2 A's to spare. So we're limited by the minimum amount that's present, but each of them has at least 1 A to spare, so we can take out an A. Now, this isn't an equation, so we can't get rid of any factors. They can't disappear because there's no other side to put them to or anything of that nature. So they have to remain present. We just move them to the outside. 8 divided by 4 leaves us with 2. A squared divided by A leaves us with A. 28 divided by 4 leaves us with 7. And A divided by A leaves us with 1, which of course doesn't change the 7. So there's your factored form. This one's a little bit tougher, but we can maybe see if there's a way to factor out in groups. So find common factors for each little group of 2. So in the first one, there are at least 2 b's in each of these terms, and each of them will divide by 3 as well. So we can go 3b squared. Okay, and if we take out 3b squared, all we're left with here is a b. So that if you multiply these two things back together, they would give you that original term. Okay, now if we divide 21 by 3, we get 7, and b squared by b squared just leaves us with 7. Now similarly over here, these things both have a 5 in common, but that's it. So we can take out a 5, and this one will leave us with a b. This one, 35 divided by 5, leaves us with a 7. Now the thing to note here is that we have two things multiplied by the same binomial factor. So 3b squared is multiplied by b minus 7, and 5 is multiplied by b minus 7. Now if they're both multiplied by the same thing, then we can write them together in a pair of brackets, because when we do this and we FOIL this, we multiply both of these terms by both of the other terms, or the entire binomial here. So writing it like this is identical to writing it like this, because both the 3b squared and the plus 5 both get fully multiplied by b minus 7. So this is the factored form, and we did that by grouping into two groups of 2 and found out that they were left with identical binomials here. Over here we have C's, here we have D's. So we can't take out any letters right now, any variables, but we do have a greatest common factor in terms of the coefficients. They will both divide evenly by 8. Right? So we take out an 8, and we're left with c squared in the first one, and 32 divided by 8 is 4, and that leaves us with 4d squared. Now, if you remember from the last page, when we were foiling, we ended up seeing a lot of things that were a perfect square minus a perfect square. So we can take this 8 and leave it out front, But this c squared minus 4d squared, if we had like 9x squared minus 64y squared, notice how they turned into the root of that minus the root of that, and then multiplied by the exact same thing with a plus sign in the middle. Okay, so we're going to take the root of this, which is c, add it to the root of this, which is 2d, and then multiply it by the exact same thing but with a minus sign in the middle this time. So then we go c minus 2d. Now you can FOIL this out if you want to double check that it will end up giving you this exact binomial term here, but you could also just take my word for it if you like, because I guarantee that it does. And this is how we're going to solve what's called a difference of squares, which we move on to now. Any difference of squares is going to be of the form a squared minus b squared. And we can always factor these as a minus b multiplied by a plus b. So we figure out what our a is, we figure out what our b is, and then we can just write it in this form. So in this case, a is x. So a squared becomes x squared. B is 4, because 4 squared becomes 16. So this is the squared version of each, but we want to get the root of each of those to plug into our thing. So we take the root of x squared and we go x plus and x minus, and then the root of this one is 4, so we go plus 4 and minus 4, and we're done. That's all there is to factoring a difference of squares. Sometimes you'll see something that looks vaguely like a difference of squares, but has something that's not a perfect square in front of it. If you can take out a common factor, sometimes it might leave you inside the brackets with a difference of squares. Okay? Now, once we remove this 2, we're left with a perfect square here, m squared, and a perfect square here. And we can factor that in the usual way. So our a is m, so we leave our 2 out front and we go m plus something times m minus something. Our b squared is 25n squared. So our b would be the root of that. So we take the root of this. The root of 25 is 5, and the root of n squared is n. And then we just write the same term in both of them. And we're done. Similarly over here, 81a squared minus 64b squared. These are both already perfect squares. So take the square roots. We get 9a plus 8b times 9a minus 8b. The order of the plus and the minus don't matter. You'll get the exact same thing if you switch them around. Okay, it's like 3 times 2 versus 2 times 3. You're going to get the same result regardless. So it doesn't matter if you go minus and then plus, or plus and then minus, as I've done here. Factoring trinomial squares. This is a little trickier. As I tried to point out earlier, we want to use the sum and product method. That means that this coefficient here is going to be our sum. Okay, the sum is always on the linear term, and this is going to be our product, and the product is always the constant term. So basically what we need to do is find two numbers that add up to minus 8 and multiply together to give you 16. Now there's an infinite number of combinations of numbers that add up to minus 8. So we don't want to start by just randomly selecting two things that add up to minus 8, like minus 5 and minus 3, because it doesn't make sense to choose two things that don't multiply together to give you 16. Now 16 has a finite number of factors. There's only a certain number of ways that 16 can be written. 16 times 1, or minus 16 times minus 1. What else? Negative 8 times negative 2, or positive 8 times positive 2, negative 4 times negative 4, positive 4 times positive 4. These are the only possible factors of 16. Now all we have to do, once we've listed all the factors of 16, we just choose the ones that give us the correct sum that we're looking for. Okay, so these add up to 17, no good, because we're looking for minus 8. These add up to minus 17, no good. These add up to minus 10. These add up to positive 10. These add up to minus 8. Here's positive 8. They don't work. These are our two factors, minus 4 and minus 4. So we break this thing down and we go a minus 4 times a minus 4. And there's our factored form. You can FOIL it out and you will end up with this if you want to do that, just as a brain exercise there. Let's move on to the same, or to the next problem here, and employ the same strategy. So our sum, we need two numbers that add up to 18, and we need two numbers that multiply together to give us 81. So let's start by listing the factors of 81. There aren't many. 81 times 1, negative 81 times negative 1, negative 9 times negative 9, and of course 9 times 9, both positive. Choose the two that add up to positive 18. Obviously not that one, they add up to 82. Here they add up to negative 82. Here they add up to negative 18. Here they add up to positive 18. So 9 and 9 are our two factors. So we go b plus 9 times b plus 9. And again, if you were to FOIL this, 9 and 9, the sum is 18. 9 times 9, the product is 81. Alright, similarly here, you might be thinking to yourself, do the factors always have to be identical, like plus 9 and plus 9 or minus 4 and minus 4? Well, you're about to get your answers, and I know that you must be terribly excited about that. So here the sum is minus 6, and here the product is plus 9. So we start by finding all the factors of the product. That can be 9 times 1, or negative 9 times negative 1, 3 times 3, or negative 3 times negative 3. Choose the two that add up to minus 6. That's 10, that's minus 10, that's positive 6. Here are your two factors, so c minus 3 times c minus 3. Alright, this one, a little bit trickier. This is going to be our sum, 20. But our product, now that we have a coefficient, an a value in front of this thing, our product is actually going to be 4 times 25. So our product is 100. So we want to find the factors of 100. Now there's a lot of them. Okay, we're only looking for positive factors here. So let's not worry about, let's not even bother with the negative ones. So let's go 100 times 1. There's 50 times 2. There's 25 times 4. 20 times 5. 6, 7, 8, and 9 do not go evenly into 100, but 10 does, and we are at 10 times 10. Okay, so we want to choose the two that add up to our desired sum. That's 101, 52, 29, 25, and finally 20. So now we rewrite the center term as plus 10d plus 10d plus 25. So we've taken these two terms and just broken this down into a sum using these two numbers. Now, that strategy we used earlier where we took out a greatest common factor by grouping into two groups of 2, this is the same strategy we're going to employ here. So a 2, Common 2 and a d will come out of these first two terms. So we take out 2d. 4 divided by 2 leaves us with 2. D squared divided by d leaves us with d. And 10 divided by 2 leaves us with 5. And d divided by d leaves us with 1, which doesn't change the 5. Similarly here, we can take out a maximum of 5 from each one. There's no d common to both. So all we can do is remove a 5. 10 divided by 5 is 2, so that leaves us with 2d. And 25 divided by 5 is 5. And again, you'll notice here that we've got 2d plus 5 and 2d plus 5. In both of these terms, 2d and plus 5 are multiplied by 2d plus 5. So we go 2d plus 5, which are the ones underlined in purple, multiplied by 2d plus 5. That was a terrible idea. Just because I underlined them in pink there, to show you that we grouped these two together to make this term, and we grouped these two together to make that term. Alright, trinomials, ax plus bx plus c, where a equals 1. Now here's where we might not necessarily have identical terms like we did on all of the last page, but we stick with the same strategy. Two numbers that add up to 8, so the sum is 8, the product is 12. So again, we have positives here and a positive here, so we know they're both terms are going to have to be positive, both factors. So let's only focus on the positive factors of 12. We have 12 and 1, we have 3 and 4, and we have 6 and 2. We want to choose the two that add up to 8, and of course that is 6 and 2. So we go a plus 6, a plus 2, and we're done. Move on to the next one. Sum, this one's a little bit trickier. If there's nothing here but a minus sign, that implies a 1 in front of the b. So your sum is minus 1, and your product is minus 6. So choose the factors of minus 6. Now, in order to end up with a negative product, you need one positive and one negative, okay? Because two negatives would make a positive product, and two positives, of course, would also make a positive product. So we need them to be opposites. So all the factors of minus 6, where 1 is positive and 1 is negative. So minus 6 and 1, or minus 1 and 6, minus 2 and 3, or minus 3 and 2. And again, we choose the two that add up to our desired sum of negative 1. That's minus 5, that's positive 5. This is positive 1. If we had had a plus here, these would have been the ones we were choosing, but we want a negative sum, so the negative number has to be the bigger of the two. And then we just write it as b minus 3 times b plus 2, and we're done. Alright, same thing down here. Our sum is plus 7, our product is 10. We only want to focus on positives because the sum is positive and so is the product. So the factors of 10 are 10 and 1 and 5 and 2. Choose the two that add up to 7. So we go c plus 5 times c plus 2. Done. Factors of negative 35. One has to be positive, one has to be negative. The negative one has to be bigger because we end up with a negative sum. So factors of 35 are going to be negative 35 and 1. We could write 1 or negative 1 and 35, but we know the negative one has to be bigger. So negative 1 and 35 isn't going to fulfill this. And we can do negative 7 and 5. And again, we could have gone negative 5 and 7 as well, but we know that the bigger one has to be the negative one. So we just eliminate a few options by taking smart guesses that our negative one's going to be bigger, and these are our two factors. So we go d minus 7 times d plus 5. So again, if you were foiling this back out, you'd go plus 5d minus 7d, which of course leaves you with minus 2. And then your product minus 35. Alright, sometimes the coefficient is not 1, and again we do this just like we did the last ones. This gets a little tricky, but our sum, we stick with the same technique. Our sum is minus 5. Our product is going to be 3 times negative 2, so the product is negative 6. So let's write out all the factors of negative 6, and those will be negative 6 and 1, negative 1 and 6, negative 3 and 2, and negative 2 and 3. Choose the ones that add up to negative 5. So these add up to 1, negative 1, positive 5. Here's our winner right here, negative 5. So then we go 3a squared, and then we just rewrite negative 5a as these two factors, minus 6a plus a. So notice that if you combine these like terms, you'd get negative 5a, but we're just writing it in a way where we can group in groups of 2. So take out your common factor here of 3a, and that will leave you with a, and then negative 6 divided by 3 is minus 2, and a divided by a is 1. And then if we took out anything from here, the only thing we could take out would be a 1 that would leave it unchanged. Alright? And again, let's group these two underlined by yellow because they both get multiplied by the same binomial factor. And then this factor is common to both the 3a and the positive 1. So we just multiply them as binomials. And we're done. Okay, same strategy. Let's keep going. I'm going to do this one quickly. A sum of 23, a product of 22. So we need to find the factors of 22, and those will be 2 and 11. And 22 and 1. These add up to 13, no good. These add up to 23. That's our winner. So let's go 2b squared plus 22b plus 1b plus 11. Take out your common factors. 2b will come out of the first two terms here, and we're left with b plus 11. And a 1 will come out of the last two terms. There's nothing bigger than a 1 that's common to these, but it leaves us again with a b plus 11. So we have our yellows here, b plus 11, and we have our blacks here, which we group 2b plus 1. And we're done. And that's all for today. I'll see you in class tomorrow.